Okay, I'm recording this session para pwede nyong balikan, no? In case na nakalimutan nyo yung mga techniques. So, ang assumption ko dito for today's session is that you've already watched the videos. So, I'll be slightly going in a faster pace, no? Pero again, yung concepts, theories behind it, I'm suggesting you just rewatch the videos. Pero more focused ako ngayon sa yung actual techniques, no? And how we can use the techniques para may palabas yung or may prove yung parallelisms and perpendicularity ng different planes. Right? So, hopefully we'll be going fast today, no? Streamline yung discussion natin. I'm estimating kaya natin matapos kahit hanggang CAD, no? Pero kung kukulangin naman tayo ng oras, then we can just cut the lesson, tas next meeting na lang tayo mag-CAD. Okay? Right, so let's start, no? Kunin nyo muna yung first module natin for today, which is module 5, Parallel Lines and Planes. By the way, give a shout out kay Sir Ken. No? Sir Ken, di ko na alam, di nyo na nabutan. No? Sir Ken was a math faculty. One of the better na faculty members dito sa department to. Unfortunately, kailangan kasi niyang umalis. So, wala na siya ngayon sa faculty. Pero siya yung naggumawa ng mga modules na to, itong mga parallel lines and planes, etc. So, shout out kay Sir Ken. Okay, so, eto, let's start with the first lesson for today, which is parallel lines and planes. And ang gagawin natin is we'll focus mainly on proving that two lines are parallel to one another, or two planes are parallel, or a line and a plane are parallel to one another. And this requires simple proofs, no? Okay? So, let's start with 2A, determining whether the given lines are parallel. And the theory is quite simple, no? And I've discussed this through the video that when you have two parallel lines, and I'll be using the terms apparently and truly parallel. No? When I say apparently, I'm just talking about parallelism in a particular view lang. Okay, so pwedeng sa HRP, FRP, or ARP, that's apparent parallelism. But when I say truly parallel, I mean their true relationship in space. Okay, so in any view, if they are truly parallel, then their relationship holds true. No? Okay, now when you have truly parallel lines, and you can test this out on yourself, no? Kunwari, may truly parallel, make it, grab two pens, tapos make it such that they are truly parallel to one another. You'll notice na kahit anong ikot nyo sa views, in all views, they will appear parallel. Okay? So, yun yung pinakasimpleng, proof or simpleng basis for parallelism is that in all views, parallel lines, truly parallel lines, will always appear parallel to one another. Okay? So now, if you want to prove that two lines are parallel to one another, kailangan lang natin ng two views. Tama? If you can show that in at least two views, the planes appear, or the lines appear parallel to one another, then we are sure that in space, they are truly parallel to one another. Okay? Make sense? Okay, so gagawin lang natin siya dito. And in fact, hindi nga natin gagamitin masyado yung natin, no? Compass for today. More of writing proofs lang tayo. Okay? So if I check this line 1 2 right here. So I'll check line 1 2. Tapos I'll use my sliding triangle to look at to prove that the two planes are parallel to one another. Lines, I mean, are parallel to one another. And if I check 1 2 is parallel to AB. Tama? So, a proof that we can write is, and this is how we write proofs, 1, 2, wait lang ha, okay, so we can say 1, 2 is parallel to AB, and this is the symbol for parallelism, no? Parang dalawang parallel lines. And we can say segment sila. 1, 2 is parallel to AB. And you can type in HRP, or pwede naman ang sabihin lang natin is lagay lang tayo ng parentheses to say that this one is an apparent parallelism that we observe in HRP. Okay? Next, we look at it from AB, from FRP, I mean. And if you look at it from FRP, we can also see that the two lines are parallel to one another using our sliding triangles. No? So we can also say that 1, 2 is parallel to AB in FRP. And because we have shown it to be parallel in two views, separate views, then we can conclude that 1, 2 is truly parallel to AB. Okay? So it's as simple as that, no? So ganun lang kasimple mag-prove ng parallelism between two lines. Right? Now, the only exception to the two views rule is if the lines themselves appear perpendicular to the fold line. Because when they appear perpendicular to the fold line, and you can hold your, I don't know, two pens like this, parang ganyan, they are not parallel to one another. This is what we call as skewed lines, no? Because they do not intersect, pero they are also not parallel to one another. Okay? If you look, hold it this way, tapos ang ginawa nyo is the fold line is here. Ang mangyayari is you're just rotating it this way. So there's no way for you to tell if it's truly parallel or not. So the way we go around that is that we create another reference plane. Okay, so whenever you have a situation like this where the lines themselves are perpendicular to the fold line, you need another view. Yun lang yung only exception to the two views na rule na sinabi natin kanina. Okay? Um and the auxiliary view that we will create can be in any angle, no? So you can create it at an angle like this. You can create it from HRP. You can create it from FRP. It doesn't really matter, no? As long as you create another view to show the orientation of the lines in space. Okay? So what I'll do is I'll just create a random line siguro. A random reference plane. So I can something like this siguro, no? Okay? Hindi ko gagawin vertical pero in most cases students just like to do a vertical line, no, or a perpendicular line to the already existing ano. Doesn't really matter. Ako I just showed it at an angle, no, itong ARP ko just to show that it can be at any orientation. Okay? Let's label our fold lines or reference plane. So this is now ARP1. And dito sa kabilang side is the HRP. So I'm drawing it from HRP, no? Moving this direction. Okay? So in this case, ang gagawin natin ngayon is we now have to create our our projections. Okay? So let me just set up my compass now. Okay. Right. So, gagawin natin is, let's create projection lines. So again, I'm projecting from HRP, but you can might very well project from FRP, no? Doesn't really matter. So I'm just projecting from 1, so 1, 2. You can do this methodically, no? Like, pwede nyo gawin is, line by line kayo. Pero what I'll do is, I'll just do it all in one go, no? Yung pag-project ng mga projection lines ko. Okay? And I'll project Y as well. And lastly, I'll project CX. So, okay. Now, we're at ARP. So, ang basis ng distances natin will be 2 views away. So, that's 1, 2. Basis is FRP. No? Okay. And I'll have to connect this na para may, so that I'll have a basis or a reference point when I'm measuring the distances. Right? So, I'll do line by line para hindi nakakalito, no? So, I'll do 1 first. So, this is the distance of 1. And 1. So, 1 is here. Mark it off. Next is the 2, endpoint number 2, which is this distance away. 2 is here. Next is, I'll do AB. So A is this distance away. This one. So A is this projection line. So, next is si B naman. B is this distance away. So, yung projection line ni B. Let's mark it. And lastly, si XY. X is this distance away. Sige lang ha. Let me adjust my pen. X is this distance away, which is here. And Y is distance away, which is this one. Okay, so now let's finalize our answers. Let's do 1, 2 first. 1, 2 is this line. 1 and 2. And let's label it as well. So there's 1.1, 0.2 is here. Then we do B and A. B is this point. A is this point. So this is B and this is A. And lastly, X and Y. Ito siya. This is X. Wait lang ah. Check ko lang yung Y distance ko. This is supposed to be parallel. This is X. And yung Y. Okay. So now I'm checking which lines appear parallel. So now we can do the same proofs again, no? So pwede natin sabihin, we can use HRP or FRP, doesn't really matter. Pero I'll use HRP as my first set of proofs. So I can do 1, 2 appears parallel to AB in HRP. But 1, 2 is not parallel to AB in ARP1. Therefore, we can say that 1, 2 is not parallel to AB. Okay? And we can do this, no? Because again, ang sabi natin, we said that for two lines to be truly parallel to one another, in all views, they must be truly parallel. Or apparently parallel in all of the views, no? And you can see that there is just one view. So one view alone is enough to say na they are not truly parallel in space. Okay? Let's do the next two lines. Let's do 1, 2, and XY. This is Y. This is X. Okay, so dito naman 1, 2 is parallel to XY in HRP. And we've checked this, no? Ito. They appear parallel and they also appear parallel in ARP1. Therefore, we can conclude that 1, 2 is truly parallel to XY. Right? And the last one is CXY and BA or AB. AB appears parallel to XY in HRP, but AB does not appear parallel to XY in ARP1. Therefore, we can say that AB is not parallel to XY in space. Okay? So that's how we do the proofs. Now, it's quite simple. Ganun lang yung gagawin natin. Again, we only need two views. The only exception is when the two views given are given in such a way that the lines, the parallel lines given are perpendicular to the fold line. Right? Okay. Okay? Same ba tayo ng conclusion? Same kayo nakuha? Okay. So let's proceed. So quite simple. When you're proving parallelism of a line and a plane, of two lines, just requires two views. Now, let's proceed with the next one, which is parallelism between a line and a plane. Okay? So, to prove that a line is parallel to a plane, we just need to show that there exists a line contained in the plane that is truly parallel to the line. Okay, very simple lang, no? So you can also imagine this in space. So for example, if I take this one edge of my triangle and I make it such that it is truly parallel to this pen, if I rotate it around, pagka nag-rotate ako ng view, I'll always see that this edge and this line is truly parallel to the plane. Now, it doesn't necessarily have to be an edge because we have also shown in previous lessons, no, that when you have a plane, there are infinite number of lines contained in the plane. Therefore, if a line is truly parallel to a plane, there must exist at least one line contained in the plane that it is truly parallel to. And in fact, it's an infinite number of lines, no? Pero there is only one unique direction that is truly parallel to the given line. Okay? So, what we just need to do is create a parallel line or find a parallel line contained in the plane and show that in at least two views, that line is parallel to the line contained in the plane. So very simple, ano? If we can prove that there exists a line that is truly parallel to the given line, then the plane automatically becomes also truly parallel to the given line. Okay? So, in this particular case, we have AB that is conveniently parallel to 1, 3. So if you can look at it, ito AB, it's conveniently parallel to 1, 3. So pwedeng 1, 3 na gamitin natin as the test line, no? Pero not necessarily an edge. We can also take another line here. So pwedeng in an infinite number of lines we can take with contained in the plane, no? Pero again, since the edge is already existing, let's just use the edge. Okay, so ito, AB and 1, 3, they'll appear parallel. So we can say that our first line for the proof is first line of the proof is 1, 2 is parallel to AB in HRP. Another way of doing it is instead of using the parentheses, no, pwedeng you can write it as like this in HRP. Some students like to do this, no? Sorry. My bad. It should be 1, 3, no? So 1, 3 is parallel to AB in HRP. So you can say that, no? Parang ganyan. Then you can also say 1, 3 again, and let's try to check. It appears parallel, pero just to double check, let's use our sliding triangle, and we can see that it is indeed parallel, no? So we can say that 1, 3 again appears parallel to AB in FRP. Okay? So we can conclude that 1, 3 is truly parallel to AB. Now, since 1, 3 is contained in or parang is in triangle 1, 2, 3, then we can make another conclusion that AB is parallel to triangle 1, 2, 3. Okay? Now, itong dalawa na nilagay ko, these two lines at itong two proofs, no? Ito, dalawa. This one and this one. Optional to. Some students omit this and it is permissible, no? In ES1 na you can skip this one, these two proofs. Okay? So you can just say 1, 3 is parallel to AB in HRP and 1, 3 is parallel to AB in FRP. Therefore, AB is parallel to 1, 2, 3. Okay? Because 1, 3 is contained in 1, 2, 3. Pero if you want to be more concise, no, you can write these additional two lines right here. Okay? But if you're in a hurry, may hinahabol kayong oras, kunwari, if it's an exam, tapos kulang na kayo sa oras, then you can just write these three, no? This is enough to show. This one just says that 1, 3 is truly parallel to AB, and this one says that because that 1, 3 is contained in 1, 2, 3, then you can conclude automatically that AB is parallel to the plane itself. Right? So I'll just say optional. For me, I just like to write it down, no? So that the train of thought is complete, no? Right? Now, let's try this one, 4, 5, 6. Let's check which line is truly parallel to 4, 5, 6 given two lines ES and YZ. Okay? So, unlike the previous condition, CES does not have a line that is conveniently parallel to the or does not have an edge. 4, 5, 6 does not have an edge that is conveniently parallel to ES. So, we can create our own, no? Kasi again, the planes contain an infinite number of lines. So what we can do is, we can start here. ES. Tapos ang gagawin natin is, let's use our sliding triangle. Tapos gagawa tayo ng, we'll be creating a line contained in the plane. Again, you can create the line anywhere you want. But it's more convenient if we use already existing points now. And for this case, the existing point that is convenient to us is 0.6. So we can do 6, then just extend it like so, such that it is parallel to ES. And we can label the other side as 6 prime. Okay? And now let's project 6 prime. Let's project it to the other side. 6 prime is in between 4, 5. So we project it towards 4, 5. So nandito siya. So 6 prime should be here. Right? So now, if I connect this one, and I'll check, 6 prime looks parallel to ES in this particular view, in FRP. Therefore, we can make the conclusion of, we can say ES is parallel to 6, 6 prime in HRP, or PRP, sorry, PRP. And when we projected it onto FRP, we also saw that ES is parallel to 6, 6 prime in FRP. Therefore, we can conclude that ES is truly parallel to 6, 6 prime. And since 6, 6 prime is contained in triangle 4, 5, 6, then we can also say that ES is truly parallel to triangle 4, 5, 6. Again, optional. This is optional. You can remove it if you don't want to add it. Okay? Now, let's try YZ. And we can see that YZ here is conveniently parallel to 4, 6. Right? So you can say that YZ is parallel to 4, 6. But when we check onto the other side, YZ is no longer parallel to 4, 6. it's parallel to 5, 6, pero it's not the same line. Tama? And for a plane to be parallel to another, for a line to be parallel to another plane, it must, the plane must contain a line that is truly parallel to the given line. But in this case, YZ is not truly parallel to 4, 6. Tama? Because this one was in PRP, no? YZ is no longer parallel to 4, 6 in FRP. So therefore, YZ is not parallel to 4, 6. And I'll use a shortcut here, no? I can also say that YZ is not parallel to triangle 4, 5, 6. So why can we conclude that the plane is automatically parallel to why can we conclude that the line is automatically not parallel to 4, 5, 6 if we only just check one line? Because there are infinite number of lines, then it can be argued, no? You can logically parang pwede nyo i-argue, maybe nagkataon lang na yung napili natin is hindi siya parallel, but maybe we can find another one. Pero, take note that in any view, there will always be an infinite number of lines that is, or an infinite number of lines that will look parallel to a given line, but there is only one unique direction that gives you that relationship. And the unique direction here is this direction 4, 6. For this particular view, no? Si 4, 6. So, lahat ng candidates is already encompassed by 4, 6. So, if 4, 6 was the candidate, it was the only candidate, and you can choose any, kaparallel niya. And again, we've said that parallel lines are non-unique lines, no? So, ito 4, 6, kayang-kaya na din niya i-encompass lahat ng mga kaparallel niya. Alright? Yung ka-direction niya, kumbaga. So, 4, 6 was our candidate, and it was shown na it is not truly parallel to YZ. Then, therefore, our only lone candidate has failed the test, no? So, meaning there is no longer any lines that can satisfy the condition. Right? So, you might be wondering, is this the only way to do this? Hindi naman, no? Kasi nagkataon lang I started in PRP, but what if I started in FRP? Even if we started in FRP, we can arrive at the same conclusion, no? But the conclusion would be, or the lines would be different, no? Parang, if we were starting at FRP, we would say that YZ is parallel to 5, 6 in FRP. And we say that YZ, if you look at it, YZ is not parallel anymore to 5, 6 here. So, it's not parallel to 5, 6 in PRP. Therefore, YZ is not parallel to 5, 6. And therefore, YZ is not parallel to triangle 4, 5, 6. Okay? So, you can use this as well, no? Depending on where you started. So, doesn't really matter kung saan kayo nag-start. You will always arrive at the same conclusion, no? Right? Okay. Now, let's do an experiment here. What if instead of looking at it using parallel or proving it using two parallel lines, what if we use the edge view instead? Okay? Kasi if you think about it, if you have a plane, tapos there is a line that is truly parallel to the plane, and what you do is you try to orient it such that the plane is in its edge view. If they are truly parallel, then it makes sense that the line will appear parallel to the plane which is in its edge view. Okay, so that is also another way to prove it, no? But again, it's a harder technique because you have to do the edge view first. So if you do the edge view, what happens is the line, if they are truly parallel, would appear parallel to the plane shown in its edge view. And let's try to do it here. Nalala pa kung paano mag-edge view. Edge view is quite simple, no? Ang gagawin natin is we find the true length first. Then after that, we make a point view of the true length. and that the point view will make it such that the plane becomes automatically an edge view. Okay, so here we can start. We can either make 1 prime here dito such that 1 prime would be true length here, or pwedeng this is also a viable solution dito, then we project it here, or sorry, we start here at 1 prime or at HRP, then project 1 prime here, and then find the edge view. This is where you need a little bit of planning, no? So you try to imagine where the direction of the solution will be. So if I do something like this, 1, 2 prime, then I note that 1 prime is somewhere here. If I move that downwards, the line will be oriented papunta dito, no? And if you look at it, the ARP would naturally be oriented this way. Tama? Because since the true length is here and we want an edge view, dapat ganitong ARP, what happens is you're moving into the bottom direction, no? And may chance na kukulangin kayo ng space. Tama? Does that make sense? Pero if I do it this way, dito ngayon, then move it upwards, what happens is it's oriented this way, but because it's oriented this way, I can make the ARP oriented this way, and what happens is I have a lot of space going to the right. Okay? So, in that scenario, most likely, hindi ako kukulangin ng space if I started from FRP. So, that's some of the considerations you can make now when you're trying to decide which reference plane you start off with. Kasi both will give you the same solution, no? Both will give the same edge view. Or both will give you a ARP that gives you the edge view, but it matters where the projected solution will be. Okay? So, again, it takes a little bit of practice, no? Ang gagawin nyo is, if you do this a few times, you'll notice that parang kaya nyo na mag-plan ahead. Hindi kayo basta-bastang nag-drawing lang ng solution nyo. You try to plan, kakasya ba yung solution ko if I go into this direction versus the other direction. Okay? So I'm looking at it. Again, what I've concluded is that starting from FRP is a better solution for me because it gives me more space to work with. Okay? So I'll start with this one. Gagawa tayo ng 1 prime. Let's do 1 prime here. And again, it's always easier if you quote-unquote recycle the points, no? So you already you use existing points. So I'll use 1 prime here, such that if I project 1 prime onto the other side here, 1 prime now becomes a true length, no? And I can project it because I'll be projecting it anyway later, no? So I'll just extend it right now. Alright, so this is now a true length. And since we already have a true length, what we can do is create the point view of that true length, and it will automatically create the edge view of the plane now. Right? So this is my true length. Let's create a perpendicular reference plane. A perpendicular reference plane should be somewhere comfortable distance away. No, we can probably get away with something like ganito ka close. Pero I think it's okay kahit we do it this way, no? Let's give a little bit of allowance, something like that. So now we can say this one is ano to? ARP. Sorry. This is HRP, no? HRP onto the left side because we're coming from HRP, diba? Or para hindi nakakalito, I'll just write it here. HRP, and the right side would be ARP1. Right? So now, let's try to project. This one for project. Let's project 1, 2, and 3 first. So this 1, 2. This is 3. And then we can project B as well. No? This one is B. And nagkataon, and I think the creator of this problem made it such the way that when you do it this way, the projection line of 1 also passes through A, no? So they share a projection line. Right? So ngayon, what we'll do is let's create the projection lines of 1, 2, 3, and AB para later on we can get the and this is the problem with using triangles like this pala, no? I'm not sure if you already noticed it. Sometimes when you try to use your sliding triangles, it snags on the, I don't know, edge when you have a triangle that has a I don't know, a hole in the center. So it sometimes snags, no? So it can get a little bit annoying, pero you'll get used to it. So ito, I'll just create projection line of 1. And again, I'm doing this because I'll be measuring distances now. This one A, and lastly C. Let's take B. Right? So, basis for distances, I'm at ARP1. 2 views away is 1, 2. So I'll be using FRP. And 2 folding lines away, fold lines away, then 1, 2. Okay? So let's do 1, 2, 3 first. So this is the distance of point 1. This distance away. So 1 is here. Next is point 2. Point 2 is this distance away. Right here. Sorry. This is point 2. So I can measure 2 here. Then distance of point 3 is this one. So it's this distance away. And if you did it correctly, then all 3 points should line up. And in my case, it did line up, no? Ito. Right? So this is point 2, point 1, and point 3. Right? And we can mark it as edge view. Always label your lines. This will be part of the criteria for checking, no? Looking at the labels. So always label the reference planes. Always label the special na orientations like edge view, point view, true size, true length, etc. etc. Okay? Now, let's project AB. A is this distance away. This one. That's A. And B is naman this distance away. Take this one. Right? And if I connect these two lines, 2 points I mean, this one and this one, I would have created a parallel line to the edge view. This is now AB, no? This is A and this is B. So you can see that AB is parallel to 1, 2, 3. Right? And the proof here becomes a one-liner na proof, no? If you did this method, which I'm not advising you to do this method, no? Unless part of the problem is to create the edge view. If it's already part of the problem or in one of the views it's already in edge view, then you can use this proof, no? You can use a one-line proof that says that AB is parallel to triangle 1, 2, 3 in its edge view, and therefore, 2 lines pala, sorry. AB is truly parallel to 1, 2, 3. Okay? So this is the only proof you need. Again, this makes sense because if it's in its edge view, and let's type in the um, let's place the view where this is true, no? It's at ARP1, diba? ARP1. So I can use a square bracket since I've already used the parenthesis here. So I can say AB is parallel to 1, 2, 3, shown in its edge view at ARP1. Therefore, AB is truly parallel to triangle 1, 2, 3 automatically. Right? And we have one more step. Pwede siguro, I can skip this part. You can look at the video, no? Pero, if I want to ask you, what happens if I show the true size of the plane? Ang tingin nyo mangyayari sa line AB natin? So, I'll just draw the orientation for how we can show the true size. The orientation of the true size would be parallel to the edge view. Tama? If we want to show the true size, we make a reference plane that is parallel to the true size. So, this becomes ARP2 and this is ARP1. What would be your prediction? Ano mangyayari sa AB? Tingin nyo. Based on the orientation of the reference plane. Itong new reference plane, ARP2. Meron ba kayong a good guess what would happen? So try to think about it. 1, 2, 3 is parallel to, the edge view is parallel to the line. The reference plane is parallel to the edge view, which means that AB is also parallel to the reference plane. And ano yung lumalabas kapag parallel yung line sa isang reference plane? True length, diba? Tama? Make sense ba yun? True length? Diba, when we're creating true lengths, we want to create a reference plane that is parallel to the line. And therefore, this just means that whenever you have, if a line is parallel to a plane, and the plane is shown in its true size, the line will be shown in its true length. And you can also think about it in terms of the, triangle and the plane. Triangle and the pen, no? So if you look at it, if they're truly parallel to one another and you show the plane in its true size, the pen will also be shown in its true length because it is truly parallel to the plane. Okay? So I won't show it here, no, pero you can try it on your own. Try to project it and you can see that the line will become a true length as well. Okay? And in the video, I showed it, no, na I projected it and it was shown to be a true length. Okay? And these observations is included in the notes that I will be giving you, no? Yung pinakita ko notes about true lengths, point views, true sizes, and edge views. I've also, parallelism is also included there, no? And this is one of the observations you can make. Right? Now, let's do parallel planes naman. And this is where it becomes a little bit tricky, no? When you have a true length, and maybe I can show it here, no, sa video. Wait, okay. Say for example, we have two parallel planes, two planes muna. And if you have two planes, we can always show that these two planes contain at least one direction or one line that is, or two lines that are parallel to one another. Okay, and they share the same direction. So for example, just to make it clear for you, I'll put it like this. So where you see the fold of the triangle, that is the shared direction. So you can see na any two planes will always share a direction. Okay, that is lines can follow that direction, right? For example, like this. But the thing about when you have parallel planes is that when the two planes are parallel, there are infinite number of directions. Instead of just one direction, instead of just sharing one direction, they are sharing an infinite number of directions. And therefore, if we want to prove that these two planes are parallel to one another, we must show that they contain at least two directions that are shared. Tama? Kasi they share an infinite number of directions. And if we show just two of them, we can already conclude that they are parallel to one another. Right? So, if it's only one direction, kumbaga, I think of it as having a sort of degrees of freedom, no? So, kumbaga, these planes have infinite number of degrees of freedom. Pero, if I fix if I say that they share one direction, it becomes only 1 degree of freedom. It can only rotate in this manner. Okay? So, yun lang. If this is shared, it can only rotate in this manner. Now, if they share another direction, so for example, this direction, and kunwari this direction, so mangyayari is, sorry, hindi ko mapakikita, no? Pero if they share another direction, what happens is, it's now locked in its position. It can no longer rotate in any direction, no? Because you are sharing two directions. Alright? So, yun yung parang theory behind how we can prove that two planes are parallel to one another. So, how do we say that they share two directions? What we do is, we must prove that the two planes contain two pairs of unique lines. Alright? So, two pairs of unique lines just means that the chosen pair, kunwari pair number 1, is not parallel to pair number 2. Okay? So, we need to show at least two pairs of lines that are truly parallel to one another. Okay? So, we choose a line contained in plane 1, 2, 3 here and show it to be truly parallel to another line that is contained in ABC, and true parallelism entails two additional views. Tama? So we need at least two views to show that two lines are truly parallel to one another. So that's our first pair. Now we choose another line contained in either 1, 2, 3 or ABC, doesn't really matter. And we show that it also has a corresponding pair onto the other plane that is truly parallel to one another. Okay? Again, the caveat is that the chosen lines, the chosen pairs should not be parallel. So pair 1 should not be parallel to pair 2. Because if you choose pair 2 that is parallel to pair 1, what you end up doing is you are just repeating the same proof, no? It is not a unique proof. Kumbaga, inulit mo lang yung proof. You need another pair that is not parallel. Okay? So, usually, when you do this, you are free to choose whichever lines, no? And again, there are infinite number of lines contained in the plane. But perhaps the most methodical approach is you take one edge of the first plane. Kunwari, itong plane 1, 2, 3. You take one edge. Show that it is parallel to at least one line contained in ABC. Truly parallel to one line contained in ABC. Then you take another edge from the second plane and show that is truly parallel to at least one line contained in the opposite plane. If you can do that 2 steps, then you have proven that the two planes are truly parallel to one another. Yun yung pinaka-methodical approach, no? Choose one plane first, then choose another plane second. Pero, if you really think about it, you can choose the two lines coming from just one plane. Pwedeng, kunwari, 1, 3, and 2, 3 yung gagamitin ko to prove parallelism. Pero, if you try to do that, sometimes it can get a little bit messy, no? If you're just working on one plane lang. So, that's why I suggest you work on two planes para kumbaga distributed yung mga construction lines nyo, if that makes sense. Right? So, let's try to see it in action. I'll choose 1, 3 first. Itong 1, 3. And nagkataon, well, ito, convenient itong 1, 3, no? Because if you look at it, 1, 3 is conveniently parallel to AB. This one. AB. Tama? And let's try to write that down. So, our first one, I'll write it dito sa notes portion, no? So, 1, 3 is parallel to AB in HRP. And if I checked it again, 1, 3 is again parallel to AB in FRP. Alright? So which means that 1, 3 is really parallel to AB. So we can say that, I'll just say, eto, hindi to kailangan, no? I'll just mark it here para lang mas malinaw. This is my first pair. So I have shown one pair. Pero when we want to prove parallelism between two planes, kailangan two pairs yung pipiliin natin. So we'll have to choose another pair. So if we choose another pair, like for example, let's say AC, let's try to find a line that is contained in 1, 2, 3 that is parallel to AC. And the way we do that is we take AC, project it, or sorry, create a line parallel to AC in using HRP first, like so. So this is 2, 2 prime. And again, this is arbitrary, no? Parang I'm starting off at HRP, pero I could have very well gone with FRP first. That doesn't really matter, no? Because if they are truly parallel to one another, then there will always be a truly parallel line in any view na pinili nyo. Right? So ito, I'll project it, 2 prime, project, this is in between 1, 3, so I'll project it here. This becomes 2 prime. And 2, 2 prime is here. And I can say that 2, 2 prime, if you look at it, they are parallel. Again, no, AC and 2, 2 prime are parallel. So, I can say that AC is parallel to 2, 2 prime in HRP. AC is again parallel to 2, 2 prime in FRP. Therefore, AC is truly parallel to 2, 2 prime. And we can say, again, this is just optional, no? Hindi kailangan isulat nito. Pero I'm just writing it down just to show you that this is the second pair. So I have pair number 1, I have pair number 2. And if you look at it, AC is not parallel to 1, 3, no? So this is a valid na proof. They are unique solutions. Pair 1 is not parallel to pair 2. So since we have two unique pairs of lines shown to be truly parallel to one another, then we can say, we can also say, an optional statement. I'll just write this as an optional statement. You can also say that 1, 3 and 2, 2 prime is contained in triangle 1, 2, 3. And you can say that AC and AB is contained in triangle ABC. Therefore, triangle ABC is parallel to triangle 1, 2, 3. Right? So, ito talaga yung final conclusion natin. Again, these are just optional statements, no? Optional. If you want to write it down. This is para lang complete yung train of thought, you know. So you're saying that yung pinili yung two pairs are contained in the appropriate or in their respective planes, and therefore you can conclude that they are parallel. Now, just an experiment. Try this on your own. I made AC, no? Pero again, you can select any line that you want. Like for example, if you try to do it with 2, 3 or BC, you should arrive at the same conclusion. And try it right now, no? Pili kayo ng gusto nyong line. Parang third pair, kumbaga. Pero unnecessary na siya, no? As long as you have two pairs, that is already enough. Pero try to find a third pair. And try to see if the third pair na pinili nyo will also be parallel to each other. And that should be the case. No? It should always be true because again, when two planes are truly parallel to one another, then there should be infinite number of pairs that can be shown to be truly parallel to one another. I'll just do it right now. Hindi ko na siya ikukwento sa inyo. Try to choose a different line than the one I'm choosing, no? Para lang mas exhaustive yung experiment natin. I'll say, in fact, I'll be, a little bit bold. Ang gagawin ko is, I'll create my own line. Like, for example, hindi ko gagamitin yung any of the edges, no? But again, this is a little bit excessive kasi if you're creating your own line, ang nangyayari kasi is, you are making yourself prone to error, no? Because you are not using precise points. If you don't do it correctly, no? So I'm just creating my own lines here. Like for example, I say this is XY. And I'll create a line that's parallel to XY. I'll just say dito, kunwari. This is UV. Now, if I try to project this XY right here, this is XY. XY is in between AB. X is in between AB. And Y is in between BC. And you can see, itong UV naman. UV is in between 1, 3. U is in between 1, 3. And V V is in between 1, 2. This one. And if I did it correctly, I can see that UV here is parallel to, oops, hindi ko naka-accurate, no? Medyo kamali lang. So you can see that UV is parallel to XY. Right? So I'll just write it here, no? Parang UV is parallel to XY in HRP. And also UV is parallel to XY in FRP. And therefore, they are truly parallel to one another. And we can say, I'll just say pair number 3. But again, this is not necessary, no? I'm just showing that there are infinite number of pairs if you really think about it, no? Okay? So again, you see how, I don't know, adding a arbitrary line here, X, Y, and UV is a little excessive because you are creating more points, no? And those additional points that you are creating are points where you can have errors, no? And you can propagate errors. So I'm always suggesting use either an edge of a plane or existing points. You can use that, no? Okay? Now, last experiment natin or last challenge natin for today is try to create a triangle ABC such that it is parallel to 1, 2, 3. Now, this one is, if it's stated like this, then this will become extremely easy, no? Kasi if you really think about it, you can just copy this triangle, no? You can copy everything, lipat nyo lang dito, and you can call it a day. It's parallel to one another, no? Parang ganon. Pero in our technical plates or in our plates and our previously in the exams, usually there are restrictions involved, no? Like for example, one edge is given, tapos you'll have to prove that the plane is, or you have to create the plane such that you have one edge given, a point given, etc., etc. So there are restrictions to it, no? when you are given these types of problems, usually what you want to do is you want to make one of the edges or two of the edges of the new triangle truly parallel to two of the edges given in the first triangle. So by doing that, kahit ano pa yung orientation ng third edge, you are sure to have a plane that is truly parallel to the other plane. Okay? So if I were to solve this problem, kunwari, no restrictions at all, what I'll just do is I'll just take, for example, 1, 2. What I'll do is I'll take two of the edges, say for example 1, 2, and 2, 3, and I'll make the third edge just arbitrary. And if I do that, then it will always be parallel to each other. No? So here, I'll just make it, see, 1, 2. I'll create a random arbitrary line there. And that line is parallel to 1, 2. And I'll make another parallel line. Let's say 2, 3 kunwari. And I'll make it arbitrary lang din. Make it like this. Now, if I take any line or any line connecting the to create the third edge, for example, I create this edge kunwari, I am sure that this new plane, if I make it such that itong two edges na to is still parallel to this edge, then they are truly parallel to one another. Okay? So, ang ginawa ko dito is, I'll just say ABC, no? So, this is now AB, ABC. So, ang ginawa natin is, first condition was, AB is parallel to 1, 2 in HRP. And I'll do it side by side, no? Para lang mas malinaw. And dito sa kabila, BC is parallel to 2, 3 also in HRP. I could probably do a table na, pero sige, hindi na. HRP. Okay? So, that's the first one. We'll need to show that it is also parallel dito sa FRP to prove their true parallelism. Kasi right now, they are only apparently parallel. Tama? Kasi it's only in one view pa lang. Apparently parallel pa lang sila dyan. So what we do is, let's create a true parallel planes by creating this one. I'll just make it somewhere, arbitrary lang naman. I'll just make it somewhere dito. Okay? But, the caveat is that it must follow the rules for projections. So now, hindi na arbitrary yung placement ni A and B. Because I've already marked A here, then A should be restricted na yung position ni A. Okay? And B, restricted na rin yung position niya. It should be here. Right? So now, this is A. This is B. Now I can mark the location of C. And sabi natin 2, 3 was the line parallel to BC. So, I'll create this one parallel to BC. And again, hindi arbitrary yung placement ni C because it is bound by the rules of the projections, no? And projection lines should be perpendicular to the fold line. Therefore, ito, C is hindi arbitrary yung location niya. It should be here. And now, I can now connect them. And I'll use a blue pen para... And this one, I'll also mark this. Right? So, if we were to... complete lang natin yung proof. So this one is AB is parallel to 1, 2 now in FRP, no? And therefore, we have proven that AB is parallel to 1, 2. And this one is BC is parallel to 2, 3 in FRP. Then we have also proven that BC is parallel to 2, 3. Ah? And because we have two pairs, two unique pairs, we can also conclude that, and hindi ko na isusulat yung mga optional lines. Sorry, optional lines, no? So I can say that triangle ABC is truly perpendicular to triangle 1, 2, 3. Okay? Because of the two proofs right here. And just to show that they are truly perpendicular talaga, we can take the edge view. So anong hula nyo? If we were to take the edge view of plane ABC or plane of plane 1, 2, 3, ano yung expectation natin sa ABC? They are truly parallel to one another, no? Truly parallel. And ang gagawin ko is i-edge view ko tong isa. If I make this an edge view, would it make sense that the other plane also becomes an edge view? Tama, no? It also becomes an edge view. So, meaning if we were to try to get the edge view of this plane 1, 2, 3, we are expecting parang ang lalabas is two lines or two edge views. I mean. And we can do this. Ito, mabilisan lang. Kaya lang natin. If you look at it, 1, 2, 1, 2 is already TL, tama? Because 1, 2 is parallel to the HRP. Therefore, this is true length. And also, since AB is parallel to this fold line, then this is also in its true length. Therefore, if we try to do this, and let's just try to do it quickly, no? May chance na lalagpas to kasi malala. Okay naman, hindi yata lalagpas to. So, let's just do this one. This one is ARP1. Ano, ARP lang. And this is FRP because isa lang naman gagawin natin. Also, if I were to show the edge view of one plane, does it also make sense na magiging edge view din yung kabilang plane? What do you think? Parang nagme-make sense din, no? If one plane is in its edge view and they are truly parallel, then it also makes sense that the third plane, or sorry, the other plane will also become an edge view. Okay? Let's just connect this so that we have a reference point. And 0.3. And let's measure distances. Let's do 1, 2 first. 1, 2, 3, I mean. So this is the distance of 0.1, which is also the distance of 0.2, no? Because they are parallel. So, magiging point view siya. Okay? Then, 0.3 is this distance away. This one, 0.3. So, ito, medyo nag-overlap. I'll just make sure touching the correct line. So, this is 0.3. This is it 1, 2 or 2, 1? Based on who is closer. So, it's 1, 2, no? So, 1, 2, and let's say 0.2 fusion. Connecting ito. And this is edge view. And lastly, project naman natin si AB. A is this distance away. And again, A and B share the same distance now because they are parallel to the fold line. This A and B. Tapos, lastly, si C, no? C is this one. is this one. And it should appear parallel now. Right? This one is edge view. Ay, ba't ko binaliktad? Anyway, okay lang yun. This is AB, tama? A is closer, so it's AB point view. And this one is point C. And if you made this view, kunwari, if you did not write this down, more concise solution would be, if again, you did the edge view, no? A more concise solution would be, you can say that ABC in its edge view is parallel to triangle 1, 2, 3 in its edge view at ARP1. Or sorry, ARP lang pala. ARP, pwedeng automatic, therefore, triangle ABC is parallel to triangle 1, 2, 3. Automatic, we can conclude that. Because it's shown in its edge view. When two planes are shown in their edge view and their edge views appear parallel to one another, automatic, they are already truly parallel to one another. But that is, again, of course, if you are creating the edge view. Pero, again, this is not a quick way of doing it, no? Because you'll have to do an additional view for you to create the edge view. So, if you are just proving without using additional views, ito yung preferred method, no? This one. Just taking two pairs. Right? So, I think we can take a short break muna. Then afterwards, let's do parallel lines. Perpendicular lines and planes. Okay, we're done with parallelism. Perpendicularity naman tayo. When we're doing perpendicularity, again, the visualization for this, panoorin nyo lang yung isang video. I'll just teach you, focus lang ako dun sa mechanical na techniques that are needed to for us to prove that two lines are perpendicular to one another. Okay? When we're proving that two lines are perpendicular to one another, the only condition is that at least one of the lines is in its true length, and it is shown that the angle that they create are is at a right angle. No? Okay? So again, only one view is needed, and as long as in that particular view, naka-true length yung isa sa lines, at least one, pwedeng both, pero one lang yung needed, one is in its true length, and they appear to be perpendicular to one another, then automatically they are perpendicular. Di na kailangan ng two views, one view lang. You only need one view. Okay? So, dito, let's try to find the true length first. So, the true length is CAB. So, let's use AB here as our starting point. Okay, so AB is a true length. Tama? Kasi if you look at it, AB is conveniently parallel to the fold line. So, which means that AB is in its true length. Now, because AB is in its true length, we can look at this and say that this is a right angle, no? And you can double check using your sliding triangles. Ito, this one, line 1, 2 is perpendicular. Okay? Or slightly lang, kulang konti. Okay? So ngayon, we can say our proof is just a one-line proof, no? Or two lines. You can say that, I'll just write it here in the notes box, no? We have 1, 2, AB, which is in its true length, appears perpendicular to 1, 2 in HRP. So therefore, AB is perpendicular to 1, 2. So that's how we write the proof. No, very simple proof. It's just two lines. One line shows na at least one of the lines is in its TL and it appears to be perpendicular. Then we can automatically prove that the two lines are perpendicular to each other. Okay? So another thing we can conclude here is that this is already in steel now. And we can say that it is not in fact, it's parallel, no? Pero ang pinoprove natin dito is perpendicularity. So we can say that AB, which is in its TL, is not perpendicular to XY in HRP. And therefore, automatic AB is not perpendicular to XY. So in this sense, having a true length is very powerful, no? As long as you have a true length in one of the views, automatically you can make conclusions, no? Okay, without any additional views, we have already proven that it is not perpendicular. Okay, we have shown AB and 1, 2, XY and AB, pero ang kulang is maybe XY is perpendicular to 1, 2. Tama? Pero we can't make that conclusion from this view because none of them are in true length. Dito din, we can't make that conclusion because none of them are in true length. Kahit mukha silang perpendicular. Kasi if you think about it, this is a trap, no? This is a trick question kasi if you look at it, XY appears perpendicular to 1, 2. Also, XY here appears perpendicular to 1, 2. And one of the things that students mistake often is parang nako-combine nila yung natutunan nila sa parallelism and perpendicularity, no? So parang nalilito sila. Parang naisip nila basta two consecutive views, mukha silang parallel, then they must be parallel to each other. And they extend that definition to perpendicularity. Parang they say if they look perpendicular in two views, then they must be perpendicular. Which is not the case, no? That's wrong. Ang perpendicularity depends on a true length. There must be a true length. Parallelism does not depend on a true length. Parallelism relies on consecutive views, no? Okay? So always remember that. This is a trick. Maraming students actually fall for this trap, no? This is always given in one of the plates, and madalas na lilito yung students, especially when they're fresh off the lesson from parallelism, no? They think it's also extendable. Okay? So ito, we can't make that conclusion. For us to be sure, what we need to do is an ARP. Kailangan, we need to show a true length first. So, let's show the true length of XY, which is comfortable distance away, something like this siguro. And this is FRP on the left and ARP on the right. And let's do projection lines. This is X. This is 1 and 2 share the same projection line. And Y is this one. Kahit, I don't know, we've already seen A and B. Or we've already proven A and B, AB's parallel or perpendicularity to both lines. We still need to show it now because, again, by default, it's always complete all views unless otherwise stated. So, unless sinabi talaga na no need to complete all views, kailangan natin mag-complete ng views. So, in this case, project pa rin natin si AB kahit tapos na yung trabaho niya. Okay? So, let's connect the lines. A and B, then X and Y. Okay, so let's do 1, 2 first. 2 views away, 1, 2. So we're projecting from here. Let's do 1, 2, line 1, 2 first. So this is point 1. And point 2 is, wait, okay. 2 is this distance away. Tama? Okay. So this is 0.1. Sorry. Point. Tama? 0.1. And this is 0.2 here. Okay. Next is C line. Let's do XY first kasi yun yung pinoprove natin, no? Mamaya na si AB. So this is point X. And lastly, si point Y is this distance away. Okay. So this is X. By the way, as a side note, no, and I talked about this in the video, in geometry, they define perpendicular lines as intersecting lines. So, technically, some of these lines are not truly perpendicular because, but in geometric terms, no, because they are not intersecting. For you to be intersecting, you must be coplanar, no? Or you must be contained in the same plane. Pero in ES1, ina-allow natin yun, no? As long as they follow the rule that there is one true length and they appear perpendicular, yun yung definition natin of perpendicularity. So it doesn't need to be intersecting. Skew lines can be considered as perpendicular lines, no? In ES1. Okay? Kasi if you look at other definitions sa textbooks, they require perpendicular lines to be intersecting. Okay? Intersecting and non-intersecting, that's a whole lesson in itself, so we will cover that in the next few weeks or few sessions. Right? So, dito, this is now sino yung true length? XY, no? XY is the true length, and we can say that XY in its true length does not appear to be perpendicular to 1, 2. And therefore, this is now, and this is in ARP. Therefore, we can conclude that XY is not perpendicular to 1, 2. And okay na lahat, no? And kulang na lang is just to complete the views, no? Or complete ARP, which entails that we draw AB. So, drawing ko lang si A, si B muna. This is point B. And this is point A. Okay? Tama? Tatlong checks lang gagawin natin, no? Kasi this is a case of 3 lines, tapos you take 2 at a time. So, ano bang combination niya, no? 3 take at 2 at a time. So, it's 3. 3 yung sagot. Tama ba? Tama. Okay? So, okay na yung proofs natin. Habol muna kayo. Tapos, may ano lang dito, Gab. Kasi, slightly smaller yung acetate. So, hindi siya nagla-line up perfectly. So, hindi ko lang, try ko i-reprint ko, no? Para mag-line talaga. Pero, right now, hindi siya nagla-line up. Baka, talaga. So, reprint ko na lang ko siya. Okay. Hindi ko alam kung bakit hindi siya perfectly kasi. So, ito yung gawa niya. Favor mo. Kasi yung iba, ngayon lang nila pinasa. So, hanap ko nang dito sa parang job ko lang. Tapos, supposedly 20 sila. So, okay? So this one, practice sa baba. Let's determine which of the given lines are perpendicular. And this is particularly easy, no? Because if you look at it, they appear parallel to one another. Meaning that if we try to create a parallel reference plane here, then automatic magto-true length sila lahat. And because they are true length, pwede natin ma-prove yung perpendicularity nila. Right? So, we can choose either HRP or from HRP or from FRP. Doesn't really matter, and equally, or both of them have the same equal space allotted, no? So, pwede tayong pumili. I'll just choose FRP siguro. Arbitrary lang. I'll choose from FRP ako magdo-drawing. Okay? So, this is now ARP. I'll just say ARP to now. ARP, then this one is FRP. Right? Now, I'll just project everything. Say X. This is Y. This is 2. This is B. Parang aligned si 2 and B, no? They seem to have the same projection line. This is 1. And this is 8. Okay? Now, let's connect them as well kasi we'll need them for basis for distances. And this one. Alright, so 2 views away, 1, 2. So, measure tayo ng distances. Let's do line by line muna. Let's do XY first. Y is this distance. Sorry. Y. X is this distance. This one. X. So, and I'll just finalize it. This is X. This is Y. And true length sila, no? Next is AB. A is this distance away. A. B is this distance away. Right off the bat, kita na agad natin na si AB is not perpendicular to XY. AB is a true length as well here. And yung last line natin is si 1, 2. So we do this distance is distance of 2. Tapos this distance of 1. Okay, so this one is 1 and 2, and we can already conclude All of them are true length now, so label natin true length. So we can say that, let's do AB first. AB, which is a true length, is perpendicular to, it looks perpendicular to 1, 2, no? So if you look at it, this is AB and perpendicular siya. Okay? So AB is perpendicular to 1, 2, which is also a true length in ARP. So therefore, AB is truly perpendicular to 1, 2. Okay? Next is, if we want to disprove the other ones, we can say that AB is in its true length, but it is not perpendicular to XY, no? It's not perpendicular to XY, also in its true length in ARP. Therefore, AB is not perpendicular to XY. And yung last line na kailangan din i-prove is XY and 1, 2, no? Which, look, just by looking at it, they are also not perpendicular. So we say 1, 2 in its true length is not perpendicular to XY, is also in its true length in ARP. Therefore, 1, 2 is not perpendicular to XY. Okay, so only this one. Only AB and 1, 2 are perpendicular in this case. Right? So, quite easy to prove perpendicularity between a line and another line. At least one lang. Only one line is necessarily or is needed to be in its true length. Pero if both are true length, you can still make the same conclusion, no? Kasi at least one lang, at least one ang kailangan. Right? Okay. Proceed tayo sa next, which is proving that a line is perpendicular. Instead of a line now, we're given a plane. So line perpendicular to a given plane. Now, this is best explained if you have if you take your pen and make it such that it is perpendicular to your desk, kunwari in your table. Notice how your pen, if it's truly perpendicular to the table, it is also truly perpendicular to all lines contained in the table. And I can probably show it better dito. So, take a look at this. Take a look at this board. There are infinite number of lines in this board. I'll draw infinite number of lines. Now, if I take my pen and I make it such that it is truly perpendicular to the board, you'll notice that it is also truly perpendicular to all lines contained in the board. Tama? So, which means that if you want to prove that a line is perpendicular to a plane, you need to show that there exist at least two lines that are perpendicular to the given line. And the caveat is, the two lines that you will choose should be non-parallel. Okay? Again, because parallel lines are non-unique lines. No? So, hindi pwedeng, kunwari, ang pinili kong first line is this one. Let's say, ito yung first line na pinili ko. Tapos ang second line ko is this one. Kasi, it's proving the same, or it's the same proof, kumbaga. Okay? You need to choose a different orientation, something like this, kunwari. So, if you have that, then that will now be the second proof. Okay? So, gawin natin. We have line AB. There are many ways to do this, but perhaps the easiest one is you take the line AB, you get a true length from the perpendicular, from the plane, you take a true length, you show a true length from the plane and check if it is truly perpendicular to AB. Because again, there are infinite number of lines in the plane, di ba? So in any particular view, and we know that the line is truly perpendicular to the, if it is truly perpendicular to the plane, then in any view, dapat may lilitaw dyan, at least one direction that is in its true length and perpendicular to line AB. Kung walang lumitaw, ibig sabihin, baka hindi talaga sila truly perpendicular. Tama? Make sense yung logic, no? So, gagawin natin is, this is the easiest way to do it, is you take true length. So, ito, for this case, 1, 2 is conveniently parallel to the reference plane. So, we can say that 1, 2 is already the true length. And if you check it, if you check this one, 1, 2 is indeed perpendicular. Okay? So, yun yung first proof natin. So, we have, I'll just write it here in the note box. No? 1, 2 in its true length is shown to be perpendicular to AB in HRP. So therefore, 1, 2 is perpendicular to AB. Okay? Next is, we need another line. So the easiest way to do that is, gagawin natin, para hindi na tayo mag-additional views, is to find the true length onto the FRP view naman, on the adjacent view. So the way we do that is, we just create a line that is parallel to the fold line. So ito, 2, 2 prime. If we create 2, 2 prime here, again, it's always easier if you recycle points, no? So ito, 2, 2 prime. Project natin, 2 prime is in between 1, 3. So dito natin ilalagay. And we say that ito, 2, 2 prime here is now a true length. And if you look at it, 2, 2 prime, 2, 2 prime is perpendicular. And hindi masyado maganda yung gawa. 2, 2 prime is perpendicular to AB. Also in, now in FRP. No? So we can say that 2, 2 prime, which was a true length, or is a true length in FRP, is perpendicular to, FRP. FRP. Therefore, 2, 2 prime is perpendicular to AB. And since 1, 2 and 2, 2 prime are in triangle 1, 2, 3, then triangle 1, 2, 3 is perpendicular to line AB. Okay? Now, a shortcut to this is, you can omit, ito no, pwede nyo actually optional to, this one, and this one. So what you can do is, 3 lines pwede nyo nang i-prove, no? So something like, kung gusto nyo shorter, no, na solution, this is acceptable kasi medyo obvious naman. You can do 1, 2 is perpendicular to true length. 1, 2 which is a true length is perpendicular to AB in HRP. Then 2, 2 prime, a true length is perpendicular to AB in FRP. And therefore, triangle 1, 2, 3 is perpendicular to AB. Pwede ganyan. Tatlo lang. Okay? Because the first one here, this is obvious from this statement. Obvious siya. This one is also obvious from this statement. And ito naman, also obvious na 1, 2, and 2, 2 prime are contained in 1, 2, 2. So, pwedeng dire-diretso lang na ganyan. And some students like to do this no, para medyo terse yung solution. Okay? So, it's up to you, whichever you find is more comfortable. No? Alright? So that's how you prove perpendicularity between a line and a plane. You just need to show that there are two lines that are truly perpendicular. Okay? Okay, using the same principles as example A, determine which of the lines ES and YZ is truly perpendicular to 4, 5, 6. So, gagawin lang natin is um, i-show lang natin that there exists a true length in triangle 4, 5, 6 in both views. And if those true lengths are perpendicular to the given lines, then the given lines are truly perpendicular to the given plane. Okay, so ito, let's do a true length first here. Ito, wala nang conveniently parallel, no? So if you look at it, 1, 2 is no longer conveniently parallel to your, or one of the edge here is not conveniently parallel to the fault line. So we'll have to create our own, no? So, again, easiest way to do this is to just create a parallel line using one of the vertex as an endpoint. So I'll just say 6, 6 prime here. And I'll project this 6, 6 prime. 6 prime is in between 4, 5. So dito natin check for project. 6 prime. And I'll also project without moving my, ano tawag dito? Pwedeng, di ba, galing tayo dito. Project natin sa kabila. Tapos, while you're here, gawa din kayo ng parallel line. So it becomes extremely efficient, no? 5 prime. Tapos, ipoproject nyo naman sa kabila. In between 4, 6 naman to. So, dito. Tama? 5 prime. Ganun. So, very efficient siya, no? So, gagawa tayo ng 5, 5 prime here. Five prime is the true length. Tapos dito naman, 6 prime is the true length. This one is the true length. So, kailangan natin i-prove na perpendicular siya. Both lines should be shown to be perpendicular to both true lengths. And we can see that only one line satisfies that condition, no? So, dito, it's ES satisfies the condition. ES satisfies, it is true, it's perpendicular. May slight, sa mali lang ata ako ng connect. It should be from here to here. Tapos, dito naman, ES is also perpendicular to 6, 6 prime. Okay? So, we can say, and I'll use the shortcut na, na proofs. Tatlo lang yung lines yung ilalagay ko. Hindi na yung exhaustive na list of proofs, no? So, I can say, ES is perpendicular to 5, 5 prime, which is a true length in FRP. Tapos, 6, 6, ES, again, is perpendicular to 6, 6 prime, which is a true length in PRP. And because I've found two lines contained in the plane that is truly perpendicular to the given line ES, then I can also conclude that ES is truly perpendicular to triangle 4, 5, 6. Okay? So again, pwede nyo gawin to, pero I suggest, if you really want to, parang track the train of thought, mas okay itong ganito because it's quite, parang detailed. You know exactly what you are proving, and from those proofs, logical yung step-by-step na arrival at the conclusion. Okay? But again, if you mastered it na, pwede naman tatlong lines lang, you can already conclude. Right? But the same can't be said for YZ, no? Tama? If you look at YZ, you can't find, YZ is not perpendicular to 5, 5 prime, nor is it perpendicular to 66 prime. And again, same logic here with yung kanina. Sabi natin, parang you might be asking yourself, well, isa lang naman tinest natin. Hindi kaya meron pang hidden true lengths dyan na magkakapag-prove na perpendicular siya dito sa YZ? So, wala ka na mahanap, di ba? Kasi again, in one view, there is only one direction that is naka-true length. So, all other lines na mapipili mo is actually just a clone, a sort of clone of this, no? Kasi parang kaparallel lang niya, nandito lang siya. Same conclusion pa rin yung makukuha mo for any true length that you want to create here. Okay? So, in that sense, since we have not found it in this view, then it is safe to conclude that YZ is really not perpendicular to the given plane 456. So, we can say that 5 prime, which is a true length in FRP is not perpendicular to YZ in FRP. And pwede hanggang dito lang, no? From here, you don't have to say 66 prime because hindi na siya perpendicular. Automatic, pwede ka na magsabi na, therefore, triangle 456 is not perpendicular to YZ. Parang ganyan lang. Okay? So again, because merong isang line, a true length, that is not perpendicular to the given 456. Okay? And you can also use the logic that, di ba, when we did the test, sabi natin, if you make this truly perpendicular to the board, dapat all lines should be truly perpendicular to this line. So, kung may nahanap ka na true length and hindi siya naging perpendicular, then hindi na na-satisfy yung all lines should be truly perpendicular to the given line. So, na-violate na niya na yon, automatic, yung buong plane hindi na talaga truly perpendicular. Okay? By the way, this case is in vectors or parang if you think about it in vectors, no, we can say that the line that is perpendicular to the board or the plane is called a normal, no. So it is the normal will also be an indicator of the behavior of the plane because the rotation of the plane also has a corresponding rotation of the normal. That's why sometimes a plane can be fully defined specifically by its normal, no, or by its perpendicular vector or perpendicular line. Okay? Right? So, dito tayo, perpendicular planes. Now, this may seem difficult, no? Pag inisip nyo, parang case ba to ng parallel lines na kailangan two pairs ulit? Two pairs of lines to be shown to be perpendicular, etc., etc. So, it's not that difficult, no? Actually, perpendicular lines are much easier than parallel lines. And the way we think about this is, let's look back at the analogy ulit, no? If you have a line that is truly perpendicular to a plane, ang scenario niya is it look like this. This line is truly perpendicular to the board. Now, try to imagine if I get any plane and I contain this line, ang mangyayari is automatic, the plane is now perpendicular to the board. Okay? So it works that way, no? As long as a line is shown to be truly perpendicular to a plane, and that line is contained in another plane, automatic, the second plane will be perpendicular to the first plane. Okay? So it's much easier, no? So ang kailangan natin gawin is, we just need to find one line inside the inside the plane that is shown to be truly perpendicular to the other given plane. And how do we prove that one line is perpendicular to another plane? Kailangan lang may two lines in the other plane that is shown to be truly perpendicular to the line. So parang step by step siya, no? Kumbaga, you prove parang this is parang line. You prove it to be perpendicular to a plane. And to prove it to be perpendicular to a plane, you need para siya, you start with line to line muna, line to line. so that you can prove line to plane, so that you can prove plane to plane. Parang ganyan siya. Step by step. So you need to know how to prove that two lines are perpendicular to each other before you can prove that a line is perpendicular to a plane. And you need to know how to prove that a line is perpendicular to a plane to prove that a plane is perpendicular to a plane. Okay? So you can work backwards then. If you have a plane, you need to prove this to prove this. Okay? Sorry. If you have this, you need this to prove this. And for this, you need this. Tama? So you can work your way backwards. Okay? So let's try to work our way backwards here. So, ang gusto natin is you can think about it in two ways. Pwedeng you find a line in 1, 2, 3 and show that it is perpendicular to ABC, or pwedeng baliktad. You find a line in ABC and show it to be perpendicular to 1, 2, 3. Doesn't really matter kung ano yung ginawa niya, no? You should arrive at the same conclusion if they are truly perpendicular to one another. Okay? So, ang gawin ko lang, arbitrarily, pipiliin ko lang si 1, 2, 3. Walang rhyme or reason, no? Sobrang random lang. Sasabihin ko lang na gusto ko maghanap ng line dito sa 1, 2, 3 and I want to show it to be truly perpendicular to a plane ABC. Okay? So, for me to be able to find that plane, I need to show two true lengths dito sa ABC muna. Tama? So, this is the easiest way to do it. In ABC, I create two true lengths. Similar to how I did it. Saan ba yan? Similar to this one, na parang nag-create ako ng 5, 5 prime and 6, 6 prime. So, parang ganun din ang gagawin ko. So, I want to create AA prime first. AA prime. And I project AA prime. This is in between BC. So, nandito si AA prime. And I also want to create AA. Mas mahirap pala to. Kasi masyadong magkadikit sila, no? Pala yung naging problema ko dahil. Kasi feeling ko ang intention ni checker dito is that parehas sila. Parang si A prime, parang true length siya dito, true length din siya dito. Para ano, no. Pero hindi ko alam kung accurately talaga siya nag-draw. So, ang gawin ko is baliktarin ko na lang kasi feeling ko magkakaproblema tayo, no. What I'll do is opposite na lang. I'll try to find a line here in ABC that is truly perpendicular to a plane, to the plane 1, 2, 3. So, ang gagawin natin, and mas okay din to pala. Kasi si 1, 2 is already parallel, conveniently parallel to FRP. So, si 1, 2 here is already a true length. So, mukhang mas convenient pala talaga gamitin si 1, 2, 3 as the plane. Okay? So, ignore nyo lang tong ano, no, A prime. Ignore nyo to. Ignore. Okay? So, that's a true length. Tapos, hanap na lang tayo ng isa pang true length which is 2, 2 prime. I want to project this 2 prime. 2 prime is in between 1, 3. So, nandito siya. 2 prime. Okay? Okay? So, ito, this is now a true length. Now, if ABC is indeed a truly perpendicular to 1, 2, 3, then it must contain a line that is truly perpendicular to 1, 2, and the TL 2, 2 prime. Tama? So, ang gagawin ko lang is I'll just create a perpendicular line to this one. Okay? So, ito yung true length 1, 2. Gagawa ako ngayon ng isang line contained in ABC, pero nagkataon BC is already perpendicular. Tama? So ngayon, BC will now be our test line. So BC, so sabihin natin, BC is perpendicular to the true length 1, 2 in HRP. Tapos, check natin dito, dun sa 2, 2 prime, BC is again perpendicular to 2, 2 prime. No? So, dito, BC is perpendicular to 2, 2 prime, which is a true length in FRP. So, therefore, BC is truly perpendicular to BC is truly perpendicular to ABC. Triangle na, no? Triangle ABC, because triangle ABC contains both contains si 1, 2, 3 pa. Sorry. That's it. Kasi si triangle 1, 2, 3 contains 1, 2, and 2, 2 prime. That's why okay din na isulat lahat ng proofs, no, para alam niyo yung logic ta. Kasi I'll write the long proof na lang para ano, no. If I write the long proof, then this should be, dapat may singit pa ako dito na ano, no, BC is truly perpendicular to 1, 2, BC is truly perpendicular to 2 prime. Pero skip ko lang yon. Pero from here, pwede kong sabihin na 1, 2, and 2, 2 prime are in triangle 1, 2, 3. Therefore, triangle 1, 2, 3 is perpendicular to BC. But because BC is contained in triangle ABC, then I can also say that triangle 1, 2, 3 is perpendicular to triangle ABC. Okay? So, again, notice the flow, no, ng logic natin. You start with a line and a line. Then after the line and the line, you proceed with the plane and the line. Then after the plane and the line, plane and a plane na. So, parang stepwise yung conclusion natin. Alright? So, parang ganyan. Haba pa naman ang oras. Pico, magbe-break muna tayo saglit, no, after nito, before tayo mag-CAD, kasi ipa-prep ko muna yung file, no, kasi as is yung PDF kasi nito, I remember hindi ganun ka-accurate siya. Nung tinry kong gawin siya, parang hindi siya nag-snap ng maayos. Tapos ang nangyayari is hindi na prove yung perpendicularity and parallelism. So, i-recreate ko muna in CAD before I share it to you. Tapos gawin natin. And we have plenty of time. Notice how the techniques are quite easy, no? And you can imagine when we go into CAD, 1:1 lang talaga yung ano nito, yung analogy niya. So since it's 1:1 lang, we can easily breeze pass through when we use CAD, no? And makikita nyo mamaya, sobrang ma-appreciate nyo yung CAD na dali lang pala mag-prove. Okay? So, last one. Using the given below, draw a plane ABC that is perpendicular to triangle 1, 2, 3. Gagawin lang natin is, let's just create a line that is perpendicular to 1, 2, 3. And dun sa line na yon, we'll just enclose it in a plane. And automatically, yung mag-create natin na plane will be perpendicular. Okay? So, ano yung kailangan ulit? We need two true lengths. So, we start here. Ito muna. 3, 3 prime. Three prime is now a true length. Tapos start and we draw another one here. That is 1, 1 prime. 1, 1 prime. And notice how hindi ko ginalaw at all yung ano ko no, yung sliding triangles, or sorry, hindi ko ginalaw yung parang base triangle ko. So by sliding it around, I have created in quick succession itong two true lengths ko, which is 1 prime. Okay? So this one, 3 3 prime here, is a true length. And here, 1 1 prime is a true length. So, ang need lang natin gawin is to just, let's just create a random line here, no? Ito. Let's create an arbitrary line here. And I'll say, itong line na to is perpendicular to 3 3 prime, which is a true length. And that same line, gusto natin gawin perpendicular dito sa 1 1 prime na to, which is this one. Okay? And I'll make it, siguro lagay ko muna siya dito. And if I make this as the endpoints, then it should follow the rules for projection, no? So, doon sa baba, hindi na siya arbitrary. Kailan ko i-project ito? Ayan, mukhang lalagpas. Dapat pala, iniksian ko konti, no? Putulin ko lang. Dapat dito lang. Para hindi ako lalagpas, no? I'll just make it hanggang dyan lang siya. So, wala to. Putulin lang natin to. So, hanggang dito lang dapat yung line natin. Para lang hindi ako lumagpas doon sa kabila, no? Kasi pag in-extend ko pa to, lalagpas na ako, papasok na ako doon sa HRP. No? So, I'll make it hanggang dyan lang. Okay? Parang ganyan. Right? So, two options. Pwedeng create tayo ng triangle as long as it passes through, no? It could be any arbitrary triangle. So, kunwari, let me... Pwedeng ang gawin natin is something like, kunwari, ito yung line na nakuha natin. Pwede natin enclose siya in a triangle like this. Doesn't really matter. Pwede rin in a triangle like this. That will still be perpendicular as long as it contains the line, no? Pero perhaps the easiest way is, if you already have the line, why not make it just an edge, no? Tapos, gawa ka na lang ng arbitrary two lines dito to make it a triangle. Okay? So, let's try to do that. Etong third one yung gagawin natin, gawin lang natin is, let's just invent a third line dito, no? Or third point dito. Again, it doesn't really matter. Parang ang nangyari kasi dyan is, let's go back to our analogy. Ito yung ano natin, endpoint. So, this is our, this is our line, and it's perpendicular to the board. If we enclose this in a plane like this, regardless of the orientation of the plane, whether it's oriented this way, this way, this way, everything will be perpendicular to the board. Okay? So think of it as a, at ito yung ginagamit kong analogy lagi. Think of it like, meron kang ground, this is your ground. Tapos meron kang flagpole. The flagpole is your line that is perpendicular, truly perpendicular to the ground. Now your flag will always be perpendicular to the ground because it contains the flagpole. Okay? So regardless kung nasa naka-orient si flag, no? So the flag could be oriented this way. The flag could be oriented that way. It's always perpendicular to the ground because it contains the flagpole, which is truly perpendicular to the ground as well. Okay? So parang pwede nyo isipin na gano'n, no? So which means that, pwede gawin natin, I'll just choose a random point here. Para yan. That random point will now create the triangle. And of course, since meron ng random point dyan, hindi na random yung magiging projection niya, no, doon sa baba. Kailangan i-follow na natin itong projection na to. Pero the distance can still be arbitrary. Tama? Kasi again, nothing is stopping us from orienting it. So I'll just place it somewhere dito siguro. Again, for this problem, free kasi totally walang restrictions ng problem na to, no? Kaya we can do these kinds of things. Pero usually, again, for plates and exams, merong mga other restrictions pa that will limit the number of possible solutions. So, ito, ang ginawa natin is ABC, no? So, pwedeng ito yung A natin, AB. This is AB. And this is point C. And the proof was AB is perpendicular to the true length 3 prime in HRP, and also AB was made such that it is also perpendicular to the true length 1 prime, true length 1 prime in FRP. Therefore, AB is perpendicular to the plane 1, 2, 3. Tama? And since AB is in triangle ABC, we can also conclude that triangle ABC is perpendicular to 1, 2, 3. Okay? So, yan yung proof natin. Even shorter proof is, pwede nyo tanggalin to, no? If you remove this one, that's an even shorter proof. Pwedeng ito, from here, you concluded that the line is perpendicular to the plane, and because the line is perpendicular to the plane containing the line is also perpendicular to the plane. So, pwedeng no, optional to. Skip nito. Pero again, I highly advise na isulat nyo yung proof that will help you with your train of thought, no? Kung paano kayo nakapag-arrive dun sa final conclusion nyo para pulido yung nyo, no? Yung thought process. Okay? Ito, fun exercise. What happens when you make the plane what happens if you make plane 1, 2, 3 a true size? If you think about it. Pag the true size, pare two planes, truly perpendicular sila. Ang ginawa mo is, tinrue size mo yung isang plane. Parang nagbe-make sense na mag-edge view, no? Tama? If you make it true size, it will automatically be an edge view. Pwede sigurong sa ano na natin ipakita no, sa CAD version. Pakita natin. Let's take a short break. 3:46. Balik tayo. Kaya siguro natin 1 hour. Kahit 4 p.m. Balik tayo 4 p.m. 15-minute break tayo. Tapos 4 p.m. Pagod na ba kayo? Kasi ako pagod na ako eh. Pero sige. Perfect ko 4 to 5, 15-minute break, re-energize lang tayo, tapos 4 to 5, try natin CAD, dire-diretso natin siya gagawin. Kung hindi, we can always, kung hindi natin matapos, we can always continue tomorrow. Okay, pause ko muna recording. Pause ko lang to. Ibahin na lang natin. Okay, so insert tayo. Again, huwag tayo mag-PDF import kasi pag PDF import natin to, walang lalabas. So, attach yung gagamitin natin. Attach. So, find the files. Let's do 5 muna. Tapos, itong 2 to 4 lang ang i-attach natin. So, you can press one page tapos shift para mag-select ng other pages. Tapos, ang gawin natin is itong 2, 3, and 4 lang muna. Yung page 1, wag na natin i-import to. Okay? So, press OK. Nakikita nyo naman. Press OK. And if hindi siya lumabas, just do zoom extents kasi baka naka-zoom out lang kayo. Kasi alam ko, again, naka-point 1 to eh. Okay? Tapos, rearrange lang natin. I'll just select one by one. Tama ba yung arrangement? Page 1, page, ito, baliktad to. Lipat ko lang. Okay. So, I should have something that looks like this. Anong unit? 1 lang. Okay. So, you should have 3. And mukhang nagsasnap naman pala. Nagsasnap siya. So, I think okay to. For now, enable lang natin is endpoint, node, intersection, perpendicular and parallel. Tanggalin natin nearest at tangent to. If we need them, we just do snap overrides. Okay? So again, ito lang muna. Okay? So let's do parallel lang muna. Ito, well, this is just, I don't know. Create a line. I'll just create CL. I'll do yellow or magenta. Do FA white. And gawin kong 0.3 ang line weight niya. And CL, I'll just add transparency at 50%. Okay? So I'm in the CL layer. Dali lang. What I'll do is I'll just put one in the endpoint. Ito. Para lang ma-prove ko na parallel sila. I can do this one, thus make it parallel and extend it. And if it follows the same line, then the two are parallel. Another way you can do it is, instead of doing that, pwede namang create a line like this. Then measure the angle between them. Kaso hindi siya na-detect, no? Hindi na-detect yung angle. So, hindi pwede. So, yun lang yung simplest way, no? Again, just hover over the line. Then, if it follows the same direction, then that is parallel na sila. Okay? Same case dito. Hover over the AB na line. Then, it follows the same direction, meaning they are truly parallel. So, same conclusion as before. Diba? Tinype natin. But this time, kailangan natin i-adjust yung, I think 0.1 yung mag-work na dimensions dito, no? 0.1. Then type in, we'll just type, nasabi natin at 1, 2 is parallel to AB in HRP. Then we also said that 1, 2 is parallel to AB in FRP. Therefore, we can conclude that 1, 2 is truly parallel to AB. Okay? Ito siya. And I can make this final answer. Final answer ko. Okay? So, pwede ganyan. So, simple as that. Ganun lang kadali mag, for parallelism. Ito, ang ginawa natin was we created a reference plane. So, I'll just do a reference plane. Pwede siguro I'll angle it like this. Again, you can also make it such that it's a vertical line. Pwede rin naman yon to make it simpler. Ito, ginawa ko lang is angled siya para lang to show that if they are truly parallel, then they will always be shown as parallel in any view. No? Okay, so I'll do text. Text. I'll specify the height as 0.1. Rotation as this. Tapos para pareho maglagay ng ARP to the left and FRP to the right. Okay. Make it as a final answer. Okay. Then you just create the construction lines. Make it perpendicular. And we can do one line at a time. So, parallel lang dito. Parallel. So, eto okay lang hindi natin i-connect, no? Kasi gagamitin natin yung perpendicular na function. So, nakikita ba yung ano ko? Okay. So, what we did was, as long as it's a perpendicular distance, parang sure tayo na it's perpendicular or is the distance from the point perpendicular going towards the fold line. No? So, ito lumabas ng perpendicular. So, I can select this. This is the location of point 2. So, point 2 is here. Then, I'll just trim. Then, let's do point 1 naman. This is the location of point 1. And I'll just trim it again. Erase this. And, lipat tayo sa final answer. Connect this one. And I'll do L weight. I'll display the line weight, no, para makita yung ano. Okay? Now, I'll project the other lines. Top, lipat tayo ng layer ulit. AB naman. A and parallel X and Y. This is X, this is Y. Just measure the distance. Let's do AB first. A is this distance. B is this distance. And lastly, X is this distance. Tapos, lastly, ito, Y. This small distance right here is Y. So, nandito siya. I'll trim this. Can erase this. Okay? So, connect lang natin. I'll use the final answer layer. Para connect natin. Nasan si X and Y. Tapos A, then B. Parang ganyan. Okay? So, let's label. Ano ulit to? A? Sorry. B. This is B. B. This is A. Always label your points, no? X and Y. This is 1 and 2. Okay. And let's try to check which of the lines are parallel. This one, if you zoom in close enough, you'll see that hindi siya truly parallel. Again, ito yung sinasabi ko na may konting inconsistency siya dahil nakaano siya. Pero if you look at it from afar, mukhang parallel naman sila, no? So again, dahil ginamit natin yung PDF version, okay lang, we can say na parallel itong dalawang to. Okay? So, let's write our proofs. proof natin is we have 1, 2 is parallel to XY in FRP, and 1, 2, 1, 2 is also parallel to XY in ARP. Therefore, 1, 2 is therefore 1, 2 is truly parallel to XY. Okay? Let's write in another proof. 1, 2, lagay ko na lang ganyan, no? This is the symbol for not. If you're doing coding, ang symbol for not is, ano, no? Parang exclamation point. So, parang is not equal to, parang ganyan, no? Pero, pwede siguro i-type lang natin not. So, not parallel, 1, 2 is not parallel to AB in ARP. Therefore, 1, 2 is not parallel to AB. And lastly, XY din, no? XY is not parallel to AB in ARP. Therefore, XY is not parallel to AB. XY is not parallel to AB. Okay? So, parang yan yung conclusion natin. Ang ginamit ko again is 0.1 na text, no? Yun yung kasya sa, ano. If you inserted it at the default scale of 1, then 0.1 yung gamitin nyo. Right? Again, madali lang ulit paano mag-prove ng parallelism. 2 consecutive views lang yung kailangan. Ito naman. Next is determining whether a line is parallel to a given plane. Only condition is dapat the plane must contain a line that is truly parallel to the given line. Okay? So, in this case, if you check 1, 2, AB and 1, 2, you check it. Mukhang parallel naman. Tama? Again, may discrepancy siya if you zoom in close enough. Nag-pull away siya. Pero, close enough na siya. And again, dito, AB is parallel to 1, 2. Follows the line. So, we can say that AB is parallel to 1, 2 in HRP. AB is again parallel to 1, 1, 3, not 1, 2. Tama? 1, 3 in FRP. And you can say since 1, 3 is in 1, 2, 3, yeah, this is an optional statement though. Therefore, 1, 2, 3 is parallel to AB. Pwede rin baliktad. AB is parallel to 1, 2, 3. Okay? Yan, simple lang yung proofs natin, no? As long as you find a line that is truly parallel to your given line contained in the plane, then that plane is truly parallel to the given line. Okay? In this case, AB is truly parallel to 1, 3, and since 1, 3 is contained in plane 1, 2, 3, automatic C 1, 2, 3 is also truly parallel to line AB. Okay? Dito, pinapacheck sa atin kung alin yung parallel. ES and YZ, which of these are parallel to plane 4, 5, 6. So, ang ginawa natin was, gagawin natin is we create a line that is parallel to ES dito. So, this is 6, 6 prime. And we project 6 prime and check if pag dito ba, parallel pa rin siya sa ES. If it's still parallel to ES, then 6 prime is truly parallel to line ES. So, ito, project ko lang. This is in between 4, 5. So, nandito siya. Allow it to intersect. And I can connect it with 6 here. I can copy this. 6 prime. And check. If I check this one, they are parallel. 6 prime is parallel to ES. Okay? So, therefore, I can place it dito sa ano, no? Dito sa gilid. I'll say 6 prime is parallel to ES in, I think this is FRP. Now, 6 prime is again parallel to ES, which is in PRP. Therefore, 6 prime is parallel to ES. And since 6 prime is contained in 456, therefore 456 is also parallel to ES. May symbol pa for therefore. Search nga natin. Baka meron. Para hindi natin tinatype. Character for therefore. Pwede pala kopyahin to. So if you want, you can copy this na. Copy ko lang to. Meron nag-create ng character for therefore. Okay? So, copy nyo na lang sa ano no. Nag-search lang ako. Character therefore. Tapos may lumabas. So, copy nyo na lang. Tapos ano. Hindi ko alam kung anong Unicode to, no? Pero, Alt 8756 pala siya. Pero, ito i-copy paste ko lang every time. Okay? So, para mas mabilis, no? Okay? Next. YZ. Check natin si YZ. YZ appears parallel to 5-6. Pero dito sa PRP, it does not appear parallel to 5-6. Tama? So, simple lang din yung ano nito. Conclusion. YZ is parallel to 5-6 in FRP. YZ is not parallel to 5-6 in PRP. Therefore, YZ is not parallel to 5-6. Tinitreat niya us. Okay? Okay. Ito. In the example below, let's draw the edge view of the plane and let's check kung ano mangyayari sa AB. If it's parallel to the edge view, then ang naging conclusion natin from before is that automatic with just that one view, it's truly parallel to the given line. Okay? So, gagawin natin is, gagawa tayo ng, if, again, ang ginawa natin from before was that if we try to do the line parallel to here, tapos pinroject natin dito, we'll look at the line and see that may chance na kukulangin tayo ng space because our reference plane will be somewhere here, tapos baka hindi papasok. So, ang better solution would be to do the parallel line dito. Para, pagka lumagpas siya dito, this true length right here is now papunta dito yung direction ng solution natin. Okay? So, now that we have this true length, ang gagawin lang natin is we lengthen this line. Lengthen natin siya, like so, para pwede tayong gumawa ng perpendicular auxiliary reference plane. So we do final answer kasi ang reference plane. I'll make it a comfortable distance away. Probably somewhere here. Tapos perpendicular. Hanapin natin. This is the perpendicular direction. And i-shorten ko lang konti to. And I could probably lengthen this part. Okay? Tapos label natin to. I'll use the TE command or text command. Hindi yung mtext. Lagay ko dito. 0.1 yung height. The rotation is this direction. I'll do HRP sa left side. Then FRP. No, so not FRP. ARP1 sa right side. Press Control Enter. So that it's angled like so. Tapos, ang gagawin natin is we copy distances, no? So, ito muna. Change back to my instruction layer. Parallel dito. Ito. And I'll measure distances. This is distance of 1. Distance of 2 is this one. Oh, mali. Then trim it. Distance of 3 is this. No, sorry. Dito ka nag-measure. Kamali ata ako sa 2. Ito ba yung measure ko? Tama naman. Okay. Now, if I connect all the points, it should line up. Again, I'm not expecting this to be perfect. If I zoom in close enough, makikita yung gap, no? Then, because it's just an approximation kasi itong PDF na to. Okay. So, ito siya. Alright? So, that's ABC. But it should look like an edge view, no? Ano dito? This is 2. This is 1. And this is 3. Now, all we need is AB na lang. AB. And it seems that A is the same projection as the true length that we created. Ito. Label ko pala yung true length na to. This is 1, 1 prime. Okay. And itong B, let's do a projection line as well. Tapos A is this distance. Sorry. Tama. A is this distance. Tapos B is this distance away. Okay. Now, if I connect this one to this one and checked it using a parallel line, I'll see that it is indeed parallel. And we can mark, I'll use a text command, EV, to say na this is an edge view. Okay? So now, dapat pala hindi ko inano to. Mark ko lang to. I'll use p-type. I'll use 0.1 din ata in absolute units. Yan. So, that is 1, 2, 3 edge view. Looks parallel to AB. This is A. This is B. So we can say text manager tayo. ABC, oh sorry, no. AB is parallel to 1, 2, 3 shown in its edge view in ARP1. Therefore, AB is parallel to 1, 2, 3. Yan yung proof natin. And lipat ko lang to the side. Hindi ata natin ginawa yung ano no, edge view. Pero ang sabi natin, ang guess natin dito or ang hypothesis natin is that if we try to create an edge view, dapat magto-true length itong si AB, no? And it makes sense because AB is parallel to the edge view. And when you create a true size, you make a parallel auxiliary reference plane. So let's do a parallel auxiliary reference plane. Let's do this one parallel to this. Change back to my construction layers. So perpendicular. I'll do a parallel dito and this one lastly parallel. Kasi A and B, this is A, this is B. Basis for distances would now be 1, 2 sa HRP yung basis natin ng distances. Let's do AB first. So this is A. This is B, sorry. Let's trim this down. Ito, erase natin. And let's do 1, 2, 3. This is the basis for 1. Ito na dito. Ay, tama ba? 1. Lalagpas tayo. Konti. 2 is this one. 3 is this distance. Tapos, let's just finalize this now. I'll use a polyline. Okay, 2, 1, and 3. Yeah, close. Tapos, I'll say true size, ano? Lagay na natin true size. While we're here, let's label. This 2. This is 1. And this is 3. Also, while we're here, let's label the reference plane. Like so. Ano yun nasa taas? It's ARP1. Tapos sa baba is ARP2. Tama? And lastly, pwede natin i-project si AB. AB. Change layer. AB. A is this distance away. A should be here. Na-trim ko na pala. Pati si B. Na-trim ko na to. Na-trim ko na pala to. So now, change layer. I'll just connect this. This is A. And this is B. And we can also say this one is a true length. True length. Gusto ko lang konti para kita. Okay? So, this is also listed in my notes, no? Pagka nakita nyo yung notes, ES1 notes, you'll see that true length, when a line is truly parallel to a plane, and the plane is shown in its true size, the line automatically becomes a true length as well. Okay? Right? Next, parallel planes. Dito sa parallel planes, kung naalala nyo, is 2 pairs yung kailangan natin. And the 2 pairs must be unique pairs. So pair 1 should not be parallel to pair 2. If you can find 2 pairs that are parallel to each other in their respective planes, then we can prove that the 2 planes are parallel to one another. Okay? We can choose any line we want, pero ang parang ano no, if you want to make it simpler, we just choose the edges kasi mas madali siyang hanapin. So if you look at 1, 3, it's parallel to AB, and we can double check by creating a line. The line parallel to this one, and you check, parang nag-align naman, so we can say they are parallel to each other. No? And let's check again if 1, 3 is parallel to AB. And you can see it's also parallel to AB. Ulitin natin. Ito, if you check, parallel. It's along that location. No? So, parallel pa rin siya. Okay? So, that's the first pair. So, para di natin makalimutan, let's just write it down first. We say that 1, 3 is parallel to AB in HRP, and 1, 3 is parallel to AB in FRP. Tama? And therefore, 1, 3 is truly parallel to AB. So, I'm doing it the long way. So, I'm proving this is pair number 1. Again, just to show you, I'll just type pair number 1. No need to write this. Pero para malinaw lang, susulat ko lang to. This is pair 1. Next natin is, let's find another pair of lines. And I'm looking at it, si 2, 3, and BC pala, no? Yung ginawa natin before, gumawa tayo ng extra line pa, di ba? Tama ba? Let's check. I think gumawa pa tayo ng extra line. Gumawa nga tayo ng extra line. Pero I'm looking at it, hindi na pala kailangan, no? Kasi if you look at 2, 3, 2, 3, and BC are actually parallel to each other, no? If you check BC, it's parallel to, ulit. BC is parallel to 2, 3. Hindi, malayo. Hindi siya parallel. Okay, so we have to create our own lines, no? So, pwede natin gawin is, we can either choose 1, 2. Let's create a line here. Pwede namang AC, create a line here. Any line will do, no, as long as we show that we have another pair number 2. I'll just use AC siguro. I'll use AC. So, I'll make a line that is parallel to AC. Like so. And I'll project this downwards. This is 2, 2 prime. I'll say 2 prime to. I'll project 2 prime downwards. It's been between 1, 3. So, this one is 2 prime. Tama? And let's check. And ito ata yung ginawa natin. 2 prime din ata ginawa ko. 2 prime nga ata yung ginawa ko. Ginawa natin dati, no? 2, 2 prime. AC din ginamit natin. Tapos, pinroject natin. Gumawa tayo ng 2, 2 prime. And we check na si AC is again parallel to 2, 2 prime. Tama? So, add lang tayo dito. We can say that 2, 2 prime is parallel to AC in HRP. 2, 2 prime is again parallel to AC in FRP. Therefore, 2, 2 prime is parallel to AC, which is our pair number 2, and therefore we can say that if we want the long way of stating it, we say that 1, 3 and 2, 2 prime are in 1, 2, 3. Tapos AB and AC are in ABC. Therefore, 1, 2, 3 is parallel to ABC. Parang ganyan. Okay? Very exhaustive na na proof. Tapos, napafollow talaga yung logic na. So this is a good way of writing it. Right? Okay, nasusunod pa naman, no? We already did this. We're just trying to do it in CAD, no? Okay, anong oras na? 4:49. Patapos na. Okay, ko pagod, low energy na tayo lahat, no? I think we can stop here. Tapos, next meeting, continue natin. Pero instead of doing the modules, I think we can do next meeting, try natin ng sample problems ng parallel and perpendicular lines. But, ano ba gusto nyo? CAD gamitin natin, no? Try natin gawin siya in CAD. Or both. Try natin gawin. Gawin ba natin both? Sige. CAD muna tayo. Para mabilis. Then, if may time pa, try natin isa pang problem na mas simple. Gawa tayo ng manual naman. Para naman ma-practice both techniques. Okay? So again, for parallelism and perpendicularity, ang essential talaga dito is mastering how to do the proofs, no? Kasi for this case, hindi accuracy yung labanan eh. Parang ang ano dito is how you can create accurate and precise na, or sorry, not accurate and precise, but how you can use logic to make conclusions. Okay? So yun lang muna. Stop the recording.